All right, so next we're going to do 2.2, and these notes say number 1. They are just only one set of notes. They're just extremely long, the set of notes, so they will take us today and then also our next class period in order to get through all of these. So 921. And our goal is going to be to graph linear equations. And then to convert between the different forms of linear equations. So we have some new vocab here. Most of this will probably look pretty familiar to you. A linear function is a function whose graph is a line. So when you graph a linear equation, it is just going to be represented by a line. But a linear function, it can be represented by a graph, it can be represented by a table, or an equation. The linear equation is one way to represent a linear function. Many of you guys will remember it looks something like this. So maybe you remember it saying y equals 3x plus 4, but we introduced function notation, and that's something that we're going to get used to is function notation. So f of x equals 3x plus 4 is what a linear equation could look like. There are other forms of it. Your independent variable is always going to be the input or the domain, which is x. In science, this is like what you can control or change. In an experiment. So that's the variable that you have control over. And then you measure the dependent variable. Okay, so the y, the output, the range. So independent variable versus dependent variable. The slope is a ratio of vertical change to horizontal change. So many of you guys probably remember this as rise over run. Some students I have had in the past like to spell rise with a Y, so they remember that it's the rise that goes on top. I don't really care how you remember it. You can also write this as the change of Y over the change of X. Delta means change. Does that look familiar? Have you guys used that symbol before for change? No? So if you want to write that over here, maybe as a little side note, this is called delta, and it equals change. Okay. I believe you guys learn it in physical science. So if you've already taken physical science, you have maybe seen it for a short burst of time there, but to figure out your change in y, you're going to take y2 minus y1 over x2 minus x1. Okay, your change in your x is the difference between your x's, the difference between your y's is your delta y. So that would be the formula to figure out your slope. The y-intercept is going to be the point on the line that crosses the y-axis. When you find this, you're not moving left or right at all on your graph. You're only going up or down on your y-axis, so it's going to be 0. You don't want to move left or right at all, and then you're going to go up or down a certain number, and that's going to be where your y-intercept is going to be. So it's always going to be 0, comma, and then some number in for y. If it's the x-intercept, it's just vice versa. You're going to move left or right, so you'll have a number for that first variable, for that x. And then you don't want to go up or down at all, so it's just going to be x, comma, 0 for the x-intercept. That's where the graph meets the x-axis. Parallel lines, this is something you guys have known for a long time. Two lines that are parallel are going to be moving in the same direction. Show me with your arms, what does parallel look like? Good. So most of you guys are like this, like they're equally spaced apart, right? So if they're a linear equation, you're going to picture like a line going on an angle. This line has to be going on that same angle. So what would you tell me about the slopes of these two lines if they have to be going at the same rate? They're equal. So their slopes are going to have to be the same. So two lines that are parallel are going to have the same slopes. Now, the perpendicular one is a little bit trickier, but this is something that we spent some time in Unit 1 learning about. And you not only have to take the opposite of it, so if one of them is going to be going towards the right and up, the next one's going to be having to go towards the right and down. So they're going to be opposite, but then also you have to take the reciprocal of it. Okay? So these are going to be opposite and reciprocals for perpendicular. And that's why we practiced both of those things back in Unit 1. Okay, so first three problems here are finding slope from a graph. So let me highlight the line here that we're trying to find the slope of. This one is the first one. In this one, it's going to be this one. And in this one, it's going to be this one. Oh, good thing you guys can't see that. You guys got to warn me about those things. I do that all the time. Okay, so you could either write out the 2 points and then find it that way, like we're going to do in our next example, or you can just count. So if this is where your first point is and this is where your second point is, remember we're talking about rise over run. Okay, so in this case we have to go down 1, 2, 3, 4. When you're going down, it's a negative amount. Okay, if you're going to the left, it's a negative amount. If you're going up or right, those are positives. Do we remember that? Okay, so in this case, we're going to go down 1, 2, 3, 4. So our rise, oh, but I did something wrong. Does anyone see what I did? You have to be very careful when you're counting on the graph. Anyone catch what I did when I counted 1, 2, 3, 4? It's going by halves. So that is the biggest mistake that I see all year long, is that people will go 1, 2, 3, 4, 1, 2, 3, 4, and then they realize, and this isn't going to matter when the scales are the same, but what happens is if our scales are different, your slope's going to be way wrong. So when I went down, I actually went from 2 to 0, which is down -2. And my run went over 1, 2, 3, 4. To the right is positive. Then I cannot leave my answer like that because I always have to reduce fractions. So -2 over 4, if you reduce it, what do you get? -1 over 2. So -1/2 is your slope here. Yes?
Is it okay if the run is -2?
So the other way you could have done this, is you could have gone up 2 and had +2. But gone to the left 1, 2, 3, 4, and had a negative run. That would be fine because, and this was a question on one of your quizzes, it doesn't matter if the negative sign is on top. That's equal to the negative sign being on the bottom, which is equal to your negative sign being out front. Those are all the exact same number. The only place on your number line you're going to find it is between 0 and -1. So those are all equal numbers. Does that make sense? Did I answer your question? Yeah. But if you had -1 over -2, that's a positive. So that would not have been the same thing. Does that make sense? Okay, so this one is a little bit different. You can take 2 points and put them anywhere because they are all they're on nice even points there. Okay, so our rise here is what? 2. What's our run? 0. What happens when we divide by 0? What happens when we divide by 0? You can put it in your calculator if you don't remember. 2 divided by 0. Can you divide by 0? No. So it's undefined. Okay. So this slope is going to be undefined. 2 points on here. What's our rise on this one? 0. What's our run? 2. What's 0 divided by 2? 0. So if we have a completely horizontal line, our slope is 0. If our line is vertical, it is undefined. Here's how I tell the story. If you have a slope that is going up and to the right, that's a positive slope. If you have a slope that's going down and to the right, so like this, that is a negative slope. Can you ski on hills that look like this and you look like this? Can you ski down hills like that? Yeah, those are some fun hills to ski down, right? Can you ski down, or I guess across a hill that looks like this? That is completely horizontal. Yeah, what's that called?
Cross-country skiing.
Cross-country skiing. That's possible, right? So you can cross-country ski. I bet it's probably 0 fun because it's kind of hard work. Maybe you enjoy it. I don't know. I'm just kidding. But maybe it'll help you remember it. So cross-country skiing, 0 fun, but lots of fun left when you're skiing on hills that look like this or like this, with positives and negative slopes. But cross-country skiing, 0 fun here. Now, picture a vertical line. Picture a vertical mountain. Can you ski down it? Well, you can try. But my guess is you're going to come back pretty hurt, or maybe have a concussion, or maybe you don't make it back. I don't know. But if you try to ski down a cliff like this, good luck. Please don't do it. It's probably not safe. So if you tried, if you survive, your memory probably won't remember it, and your ski trip's undefined. So that's how you know that the slope of that straight up and down one is undefined. Does that kind of help remember that? Have you ever heard that before? You heard it from me, didn't you? Oh, okay. Okay, so hopefully that ski story will help you remember which slopes are undefined, which slopes are 0, and what you can actually find a number for. All right, so then next is we're trying to find slopes from a point. Okay. So you have to label which one's going to be point 1, which one's going to be point 2. It does not matter which one is point 1 and which one is point 2. But this would be like x1, comma y1. And this would be x2, comma y2. And then what we're going to do is we're going to plug it into this equation up here. The y2 minus y1 over x2 minus x1. That's how we find slope. That is a formula that you will have to know. So our y2 is 3. So I'm going to write that one first. 3 minus y1 is 9 over x2 is 0 minus x1 is negative 3. Are we okay to where I got all those numbers from? Do we see where I got those numbers from? Some people are nodding. All right. So in that case, then on the top, what I have is 3 minus 9 is negative 6. This turns into 0 plus 3, which is 3. Can I leave my answer like that?
Yeah.
No. That's just negative 2. So negative 2 would be our slope in this case. Okay. Now let's say you made this first one x2, y2, x1, y1. What would happen is on the top you would have had a positive 6, and on the bottom you would have had a negative 3. So I did that in this example here. And I still get negative 2 in the end. It's just 6 divided by a negative 3 instead of negative 6 divided by positive 3. So it'll still work. Like I said, it doesn't matter which one you assign as point 1 and which one you assign as point 2, as long as your y2 and x2 are over top of each other. So your 3 and your 0 have to be over top of each other. Your negative 3 and your 9 have to be over top of each other. Does that make sense? So whatever you pick to be point 2, you have to stick with that point as point 2. Whatever point you pick to be point 1, you got to stay with it to be point 1. All right, so then here are some examples. So if you end up getting 0 on the top, what is 0 divided by 4? 0. But what happens when you try to do 4 divided by 0? What do you get? undefined. So you just have to make sure you know the difference between which one's 0 and which one's undefined. Also, if you were to do that from points. If you're not sure, when you're given the points and you find this, and let's say you don't have a calculator, picture where the points are at, okay? If your rise was 0, but your run was 4, this is what your graph would look like. And can you ski across it? Yep, so you're going to have an answer. Whereas this one, if you rise 4 and you don't run any, left to right, can you ski down that? Nope, so you're not going to have an answer. So kind of do a little sketch of it, and you'll be able to maybe relate back to that ski story, and it might help you out a little bit. So how do you use slope to graph? Okay. -1 over -2 says that your rise was down 1 and your run was left 2. Is it okay if you also thought about this as up 1, right 2? Yep. So if you have, I don't know, maybe your original point's right here. You could have gone down 1, left 2, but you're going to have the exact same pattern if you would have gone up 1, right 2. It's still going to create the same pattern, whether you're reading it and going down 1, left 2, down 1, left 2, or up 1, right 2, up 1, right 2, up 1, right 2. It does not matter. It just means that you're going to different directions on the line. All right, you have 3 more. Go ahead and try them. There we go. So this one you can go down 3, right 4, or you could have gone up 3, left 4. So down 3, right 4, or up 3, left 4. Doesn't matter. To come up with those 2 points, you're still going to get that. This will be a positive slope. This is a negative slope. This is a positive slope. This is a negative slope. Okay? Up 3, right 1, or you could have gone down 3, left 1. So, and it all kind of depends on what your graph is, where you're at on the graph. Sometimes you run out of space as you're going to the right, so you got to go to the left some. So that's why you have to know how to move in both directions. Okay? All right. So the first form of the linear equation that we're going to talk about today is the slope-intercept form. And this is the one that probably most of you guys remember, where it's written as y equals mx plus b. Does that look familiar? Yep. Cool. All right, so if that looks familiar, hopefully this will be pretty simple then. Do we remember what the m stands for? Slope. Yep. Do we remember what the b stands for? What was it? The y-intercept, yeah. So your y-intercept, and the way that we're going to write it, because your y-intercept should always be written as a point, is going to be 0, comma, b in this case, because your b is your y-intercept. So remember I said your y-intercept is always 0, comma, a number. In this case, that number has to be b. That's the only one we're going to talk about today. When I see you next, we will talk about point slope form and standard form. So all of these are written in the exact same way. So what we can do, though, is up here we're given an equation, okay? We can write a linear equation in multiple ways. There's also information you can get from them, but it doesn't matter which form you write it in, the graph's always going to be the same. The y-intercept will always be the same. The x-intercept will always be the same. The slope is going to be the same. So it's kind of like when I talked about nicknames earlier, we can take this linear equation, and it doesn't matter if we call them Tom, Thomas, Tommy, it's all going to be talking about the exact same equation here. Okay? So, In this case, when we're looking at this equation, what is something that you can get from this because this is slope-intercept form? Go ahead. Yep, so the slope I'm going to write right here, m equals negative 1/2. So that's the first thing I'm going to write. What else can I get from slope-intercept form? Jake? And where's the y-intercept at? Oh, but I can't just write negative 4. I'm not going to write b equals negative 4. I'm going to write it as a point. So I'm going to write 0, comma, negative 4. Okay. What else do I have? What else could I figure out? Do I know what the x-intercept is?
No.
I don't know, but I could figure it out. Remember how I said your x-intercept is x comma 0? You have an equation and you have the y value of it. So what we can do is we can plug it in. 0 equals negative 1/2 x minus 4. Do you know how to solve an equation like this? Yeah. So we can solve for x by adding 4 to both sides. Multiply both sides by negative 2. And we found x. So then what we'll do as our final step is we'll write it as an actual point. So negative 8, comma, we plugged in 0 for y. Okay. Ooh, we talked about the parallel slope and the perpendicular slope. What would the parallel slope be? What did we say about the parallel slope? It has to be the same. So that means that this is also negative 1/2. And what was the rule for the perpendicular slope? Opposite and reciprocal. So we have to take the opposite here, so we know this has to be positive. And then what would the reciprocal be? 2 over 1. So our slope is just 2, because we don't have to write it over 1, because over 1 is just what it originally was. Are we okay with that? All right. Then, standard form. We're not worrying about that part yet, because we haven't gotten there. Slope-intercept form, what is it? Oh, wait, that's what was given to us, right? Okay, so we'll just rewrite it. Y equals negative 1/2 x minus 4. Point slope form, we're not going to worry about that one yet. But we are going to graph this because we know some stuff about this and we should be able to come up with a graph. And I'm going to want to put both my x-intercept and my y-intercept on here. So I'm going to kind of put this here. And this one here. So then I can fit both of those intercepts on there. I'm going to make sure that I have a scale. And then remember, this graph, it has to meet all of these things, not the parallel slope and the perpendicular slope. We're going to get there later as to why we're finding those. But when I go to graph this equation, what's one thing I know by looking at this? That the y-intercept is at 0, negative 4. So I'm going to plot that one first. And I also know my slope here is negative 1/2. So how does that move on a graph? How does negative 1/2 move as a slope on a graph? Am I going to go up or down, left or right? Yeah, you can do it that way. Up 1, left 2. And I have a scale of 1 on here, so that'll work. Or I could have gone down 1, right 2. Oh, look, there's the y-intercept, or the x-intercept that I just graphed. Where's the x-intercept located on my graph? 0, negative, or negative 8, 0. Is that where it was supposed to be? Based on my math over here? Yeah. So all of it ties together. So when you get your graph, make sure that all those properties that you found are actually accurate based on our graph we did. Okay, so in the next example, I'm given the slope, and I'm given a point. Well, I can write down my slope right away. I could write my parallel slope. What's my parallel slope going to be? Yeah, 7. What's my perpendicular slope going to be? Opposite and reciprocal. So it has to be negative, and then 7 over 1 becomes, flip it. So it has to be negative, and then 1 over 7. We're not going to worry about standard form. We're not going to worry about point slope form. Now, this other stuff, we don't have an equation, so it might be a little bit hard, but could we graph that maybe? Could we plot the point 3, 4, and then use the slope to find more points? Yeah. Let's try it. So let's plot that point 3, 4. So there's that point 3, 4. And then the slope was 7. Oh, shoot, my point is up here. So how could I move to find the next point? We go down 7. And left 1. Oh, no, this isn't going to work very well. What's weird about this graph? And it's okay. So we're just learning about this right now. But what's wrong with how I'm graphing this right now? See how you can't see where that y-intercept is going to be? Mm-hmm. So we might have to kind of like say, okay, if that's at negative 3, where would the next one be at when you go down 7? For this one, where's that one going to hit at? If this one hits, we're going down 7, right? So we went down 7, we're hitting at negative 3. Negative 10 would be the next one. And then to go over one more, we'd have to hit at negative like 17. So you might, if you don't have the space on your graph, then you might do some mental math. And now we could actually write, though, our slope-intercept form because we know where it's going to hit that y just because we visualized it. So where's our y-intercept at? What's that point? 0, negative 17. And my slope-intercept form, I would write it y equals, my slope was 7, x minus 17. Now, there are other ways to get to here, and that's what we're going to talk about on Wednesday. So we will finish this on Wednesday when I see you guys next. But I'm going to tell you which ones I want you to go through and actually fill out on the notes. So if we turn the page, nope, you can skip everything in 3. I want you to fill out what the slope is and what the parallel slope is here. You're not going to do anything more on that one. And you can do this all right now before we leave. And then on example 5, you can figure out what the slope is going to be. And That's it. So you're just figuring out your slopes in the rest of them, in those couple that I showed you. So go ahead and you can do that, and then spend the rest of the time finishing your 1.1. And on Wednesday, we'll finish these notes.